Welcome back to part 2 of the world interaction and generation tutorial. This part will be about how to do more with our world generator. So we know how to set blocks, we know how to make the world generator call this method whenever a chunk is generated. So we can do generation when in fact we've done some generation already. So now how to create a flag, and only occasionally, we are not going to do it every chunk, but maybe every so often, and we don't always want to have it in the corner of the chunk. So there are techniques we can do, and let's do that now. So what we can do is we can make it so it only will do about 1 in 10 chunks. Let's say that. So we could do maybe we could do a random. So we could do if random next integer 10. So this means it will generate a number from 0 to 9, and we're going to check if that's equal to 0. Then this statement has a 1 in 10 chance to run. So once every 10 chunks on average. So we can do it from there, and we also want a random position within the chunk if we are going to generate a flag in a chunk. So we can do x equals the chunk x, and we needed to multiply it by 16, and let's also add a random number to that of 0 through 15, because that's the entire chunk. And we can repeat this process for the z part. So there we go, we've got our x and y, x and z, and we could do random y. Let's just leave that at 30 for now, and I think it would be nice to create a new method for this. Private void generate flag. We're going to place down blocks, so we need to have access to a world to place down blocks. We need to know the x, y, and z, and I think that's about it. If you are going to make a flag that's a bit random, so big flags and small flags, you could pass the random parameter as well. But we're going to make just the same flags all over again. So let's do a generate flag, give the x, y, and z, and let's give the world. So, let's envision this. We're going to generate a pole. So let's do a pole of 10 high, sure. And we've seen this in the previous example, or in the very first example on the right click thing. We should actually remove this before I make any mistakes. So let's generate 10 blocks on top of each other. So we're going to do a world set block x, y plus the y, z, and let's do a wooden pole. So let's do blocks. It should be fence. We can use fence probably. Fence. Oh, there you go. And let's do it the right way. We don't need to create a block update when we do. So let's do that. So we're creating a fence pole. Shall we check how that looks? Let's just do that. So there we go. So about 1 in 10 chunks gets a pole. And it also should have been, there we go, on the random part in the chunk. And you need to look at those 14 and 6 in X and Z part, and then the between the brackets. So that seems to be working. It's looking good. So let's now attach a pole to it. So we can do, or a flag. Oh, I don't have creative tab, so I can't find it. So let's do a GIF player, advanced touch flag. So let's make it like this, or just that. Now let's make it a bit bigger. Like that. That should do. So from the topmost block, let's work it out. So from the topmost block, well, that's set block X, Y, and then plus 9, because 0 through 9 equals 10 blocks. And then Z mob blocks and X plus 1, so therefore it won't place it right where this pole is, but one next to it. So you will find that that world generation basically is a puzzle, and usually can you get away with doing for loops placed at a right place. There we go. So 3 long, and do X plus 1 plus X. Oh. So used to using Y to using I. So that's for the X direction. So this will place down. This code right here will place down that. But it will also place down the bottom 2 layers. So we can do more layers by doing. Oh, wait. Let's do DX. We can do more layers by doing this. And let's do dy. And do... We're going to... This is y plus 9, y plus 8, y plus 7. So from y plus 7 to y plus 8, y plus 9. So y plus 7 plus dy and then that. I hope you can follow this. Let's see. So hot code replacement again, so we should be able to see what has changed already. And there you go. Our flags are being spawned. It isn't really a Dutch flag. It doesn't have 9 lines, but it will do. So I went to the Nether, and there's a problem. There are flags being generated there in the Nether, and I didn't really specify it, but I don't like Dutch flags in the Nether. I like Dutch flags in the Netherlands, but not in the Nether. So we need to resolve that, or actually, what's causing that? And that's because this I will generate is being called for every world that is being generated, including Mistcraft ages. So if we want to make it so that only this being called, well, this is only being called when we are in the overworld, we need to add some code for that. So I've told you that this world can be the overworld, or the Nether, or the end, or any Mistcraft age, or whatever dimension. So we need to extract that info. We need to know which dimension this world is. We can do that by doing doing that. So let's just not pay attention to the world provider for now, but this dimension DD contains the idea of the idea of the dimension. And well, the Java doc says though, -1 for the Nether, 0 for the overworld, and 1 for the end. And anything, there can be a lot. The other ideas are available for custom dimensions. So we could make it so it only will work for the overworld. And that way you can just trust me, this won't happen. And also the end won't be filled with this. This does have a problem though, and that is that the flags won't be generated in Mistcraft ages. If we want to do that, we actually should exclude the Nether and the end instead of including the overworld. So we can do that by, if the dimension is not equal to 1 and it's not equal to -1, we can generate. And this looks a bit dirty. We can improve the looks of this, so we can do public void generate surface so we can do like we can format this, and I'll be right back. That's more like it. So we first get the corner of a chunk XYZ or XZ by multiplying by 16, and then depending on the dimension we execute the surface, which also gets executed whenever the dimension is not the Nether and not the end. Oh, that's a bug. Like that. And it's not the Nether and not the end, it will also generate on the surface. Another thing we want to do is not hard code this 30 over there. What we can do is do a random value, but actually I think the best thing would be that we generate a flag right on top of the topmost block of a certain coordinate. This is easy for flat worlds, but how about normal worlds? Well, there is something in world get height value, which will get the height of the y coordinate of the block at a certain xz value. So we can do random x, random z, and it will return the topmost block height, and we can use that for the flag. We leave the default wall generator for now, so we can see this in action. And be right back when I find a flag. And there you go. All flags on different height levels. And you can see they are spawned on top of trees as well. And also in the water. Now we can prevent that as well. You can't really prevent these small ponds, I think. Nope. You can't prevent spawning them on top of rivers though, because you can check if a certain XYZ coordinate lies within a certain biome. So you can prevent that. by checking the biome, and you can do that by doing if world dot get biome gen for course. So it only will take the x and z coordinates because the y doesn't really matter. The biome can't change according to the y. So random x and random z, and if that isn't equal to biome, I've looked this up. The same with the blocks class, which is a list of all blocks. There's a biome gen based class, which is a list of all biomes, and you can check those. For instance, the river or whatever. So let's do that. Biome gen base river, and it's not equal to world. Whoops. Biome gen base ocean. This will only work for those river and ocean occasions though. It will fix these problems, but it won't fix a flag landing in a pond. We can do something like this though, and that's why I teach you how to get blocks in the world. We could check the block which is going to be used to generate on top of. We can check that if it's a water block, so we could do if maybe we can also check if it's not lava or so let's check for water and lava. If it's not equal to world dot not world dot blocks water, and it is nice to cache that, so we can do block equals that, and we also want to check the block below the to be generated structure and not the potentially air block. So if the block something other than water and it also isn't lava, we can generate the flag. Now there is a problem, which is that there are two blocks for water and two blocks for lava. One block is when it's not flowing, and the other block is when it is flowing. This is pretty nice seed still. I think all the well generated blocks are not flowing, and I think I've got the right block in that case. So let's check if we can find an ocean or a river and be right back. So this visualizes pretty clearly big lakes, but there isn't anything that is spawned on there. So that went well. And that mainly concludes this episode on world generation. However, as an extra, I'm going to show you how to do ore gen, because that's the most requested thing to do with WorldGen. And to do that, we aren't going to write our own algorithm to make this happen. Why would we reinvent the wheel? Minecraft has something for that. It's called WorldGen Mineable. And it's a class we can use, and it's being used in, let's see, Call Hierarchy, in Dirt, Gravel, Coal. It all uses this class, and it just passes the block it wants to generate and the vein size. So we could do that as well. So let's create a instance over here. Private WorldGen Mineable flag gen equals new WorldGen Mineable, and do mob blocks touch flag, and let's create a really big vein size, 32. That should do. So it's can be found easily. Flag gen. So we've got this instance ready to be used. Let's generate in the surface only, and let's do it. Whoops. Let's do it 5 times per chunk. And we can use this code. And we don't want to do it at the surface. We could do y plus random dot next int. So maybe let's generate it from y level 20 to y level 60. So that's it begins at 20, and it can add 40 blocks to get at 60. So between 20 and 60. So that's random dot next int 40. So if this gives us 0, it will be at level 20. If this gives 39, which is the max it can give, it will be at 59. So that's good enough. And anything in between, of course. Whoops, that's not y plus. And let's also move it over there. I like to or it like XYZ. And do a flag generate, give it the world, give it the random, the x, random x, random y, random z. Oh, and there we go. We didn't add a method this time, but we did add a member variable, and the hotcode replacer doesn't like that either. So Parmars teaches you how to do config options, so you can make this a config option, and you can also make the vein size a config option like that. You should know how to do that, so I'm not going to go into that. I'm just pointing out that you can use this. Let's create a new world. That's the thing with world generation testing. You're always going to lose your test world. So let's see if we can find our ore. Probably not on the surface. Maybe in this cave? Should be reasonably easy to find. Video settings bright. And be right back when I find our ore. Or not. And there it is. So that's a vein of our flags. Have a look, it's a really big vein. And that's because we specified it to have 32 blocks. So I think with this we can conclude this lecture. So thank you all for watching. See you all next episode when we will be covering sounds. And goodbye.